Hi class, today is Illustrative Mathematics Unit 4, Right Triangle Trigonometry, Lesson 8, where we talk about the sine and the cosine in the same right triangle. And before we begin this, I'd like to review a couple of the homework problems in order to reinforce our approach for these type of problems. So here we have a problem. Let me see, move my video over a little bit. If Mai is visiting the Eiffel Tower, she went to France and she goes to Paris. The Eiffel Tower, we want to know how tall it is. And so if I were to draw this picture of this, here's the Eiffel Tower. Doesn't look like the Eiffel Tower, but this is going to be what we're looking for. So I'll call it X. And she's standing 80 feet away. And we want to know how tall it is when we know that the angle that she's looking up at is 85.7 degrees. So the way that we set this up, and this is going to be like for all of our problems, the first thing we're going to do is we're going to write down the trigonometric ratios. SOHCAHTOA is the acronym to help you, it's a memory aid to help you remember which ratios are which. The sine is the ratio of the opposite divided by the hypotenuse. The cosine is the ratio of the adjacent divided by the hypotenuse. The tangent is the ratio of the opposite divided by the adjacent. So we write SOHCAHTOA. The second step is to mark the drawing. So label the drawing. And what are we going to label it? Well, we're going to label the hypotenuse. If this is my right angle, this would be the hypotenuse. And from the angle that I'm given all the way across, this would be the opposite, and this last one would be the adjacent. Now, why do we do these two things? We do these two things so that we can set up the ratio. And we want to choose the right ratio. Well, I'm given the adjacent, and I'm looking for the opposite. So which of these three ratios do I use? Do I use the sine? No, it's got the hypotenuse in it. I don't care about the hypotenuse. Do we use the cosine? No. The trigonometric ratio we're going to use is the tangent. It sure is loud in the other room, isn't it? The tangent of the degrees, 85.7, is equal to the ratio. What ratio? The adjacent, the opposite over the hypotenuse. The opposite is x. The hypotenuse is 80. So if I cross multiply, I get 80 times the tangent of 85.7 is equal to x. And I can plug this into my calculator, which I'll do right now. So I have 80 times the tangent of 85.7. That gives me 106, I'll write it down, 1063.96. Wait a minute, I only want it to one decimal. So if I'm going to round it, this is more than 5, I have to round this up plus 1. So it's going to be plus 1 here in this column, this placeholder. So I have 0, 4. It's 1064.0 feet. That's how tall the Eiffel Tower will be. Okay. Now, in today's lesson, the first thing we're going to do is the objectives. I can explain why the sine of beta is equal to the cosine of 90 minus beta. What's with this beta thing? Well, out of honor to the Greeks who gave us geometry, we're going to use Greek letters. So instead of calling it angle B, we're going to call it beta degrees. And you'll notice that this is 90. So these two acute angles in this right triangle have to add to 90. So if I subtract beta from 90 minus beta, I'm going to get this angle. And all that we're saying that the objective is for you to be able to notice that the sine, and let's do SOHCAHTOA. Sine is opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. So I've got the sine of beta degrees, which is B over C, the opposite over the hypotenuse, is equal to the cosine of its complement. That's this angle of 90 minus beta. Well, the cosine of this is the adjacent over the hypotenuse. Adjacent to this angle is B. and but they're the same. Yeah, that's what I'm trying to get you to see, is that they're the same. And we'll talk about this more later. But first, in the lesson, we had which one doesn't belong. And the idea is for you to use your powers of observation. You may notice that this is not a right triangle. You may notice that you can't solve for this one. Maybe you notice that this x is on the hypotenuse. These other x's are all on the short, the variables are on the short side. This one has a y in it. It doesn't even have an x. So there's some things you could notice. And if you look on page 5, you can see different reasons that students have given for why the one doesn't belong and the other one doesn't belong. On page 6, we did an activity which involved these pictures. Now you can go to there, or you can just go down below. You either do the problems that are in the A column or the B column. It turns out they both should be the same. And there's 3 problems that we go through. I'm going to go through those now, and I'm going to spend the time to do it. But I'm going to cut short the rest of the lesson. I'm just going to skip from there to the lesson summary and to the exit ticket. So let's talk about these 3 problems. My first step in each of them is to write down SOHCAHTOA. Second thing, I'm going to label the drawings. This is the hypotenuse. From this angle, this would be the adjacent. This is the hypotenuse. From this angle, this would be the opposite. I'll set them up in just a moment. For the second problem, from this angle, this is the hypotenuse, and this all the way across is the opposite. This would be the hypotenuse, and this would be the adjacent. And in the last one, we have hypotenuse, all the way across is the opposite. This is the hypotenuse. Since that's the opposite, this would be the adjacent. Now that I've written my SOHCAHTOA, my trigonometric ratios, and I've labeled the drawing, I can choose the ratio that makes the most sense for me with that drawing. Adjacent over hypotenuse, that would be this one. So I'm going to use the cosine. Cosine of what? Of my degrees for my reference angle. 41 is equal to the adjacent 7 divided by the hypotenuse, x. For this one, opposite of, that's the sine. So it's going to be the sine, not of 41. It's the sine of 49. This is my reference angle. Is equal to the opposite 7 over the hypotenuse. Wait a minute, 7 over x, 7 over x, these are the same. If you'll notice, this is 41. This angle has to be 90 minus whatever that angle is. It's going to be the complement of it, because the 3 angles have to add to 180. Since this is 90, these two have to add to 90. 90 minus 41 plus 41, that's 90. What is 90 minus 41? Isn't that 49? Oh, that's the same as here. From this angle, going all the way across, this would be the opposite, and this would be the hypotenuse. Well, the opposite of the hypotenuse is the sine. The sine of 49 is the same as the cosine of 41. That's the idea we're getting at. We'll solve for x in just a moment. Looking at this third one, I've labeled my sides. Opposite and hypotenuse, that's the sine. The sine of 65, opposite over hypotenuse, is equal to y over 6. Here we have the cosine, adjacent hypotenuse, cosine. The cosine of 25 is equal to y over 6. Y over 6, it's the same thing. Cosine of 65 should be the cosine of 25. Let's solve each of these. To solve each of these, I cross multiply. X times the cosine of 41 is equal to 7. Divide both sides by cosine of 41. X is equal to 7 divided by the cosine of 41. I put this into my calculator, and I get, let's see if I can find my calculator. Seven divided by the cosine of 41. I get 9.3 when I round it to one decimal. So x is equal to 9.3. Here, cross multiply. X times the sine of 49 is equal to 7. Do the inverse operation. Inverse of multiplying is dividing. I divide both sides by sine 49. I get 7 divided by the sine of 49. And when I plug this into my calculator, 7 divided by the sine of 49, I get 9.3. It's the same value. Isn't that amazing? Wow. Well, of course it's the same because these are the same. The sine of 41 is the same as the cosine of 49, or the sine of 49 is the same as the cosine of 41. Here, multiply both sides by 6. When I do so, this cancels, and I get 6 times the sine of 65 is equal to y. Here I multiply both sides by 6. These cancel, and I get 6 times the cosine of 25 is equal to y. And I can do this and plug it into my calculator. So I get my calculator. 6 times the sine of 65, 5.4. Here we do 6 times the cosine of 25. So it's the cosine of the complement of this one, and I get 5.4, the same answer. Are you amazed yet? Do you recognize what we're doing here yet? Let's try one more. In this one, did I not set it up? I guess I didn't set it up. So I'm going to use opposite hypotenuse. This would be the sine. The sine of 50 is equal to 8 over z. I end up with z is equal to 8 over the sine of 50. If you don't believe it, try working it out. Look at the previous problems to see why I got this. Here I have adjacent hypotenuse. That's the cosine. Cosine of 40 is equal to 8 over z, the adjacent over the hypotenuse. And I end up with z is equal to 8 divided by the cosine of 40. When I plug this into the calculator, I get 8 divided by the sine of 50. That's 10.4. Z is equal to 10.4. Here, when I plug 8 divided by the cosine of 40, 8 divided by the cosine of 40, we get 10.4. It's the same thing. And why is it the same? First of all, let me point out that the Greeks gave us geometry. To honor them, we use Greek letters. We often use theta or beta or alpha. Maybe you're familiar with pi. We don't use that for an angle, but we use these others for angles. Maybe you're familiar with delta. Each of these Greek letters has some special significance in not only in geometry, but in mathematics. We use different ones. We told you from the beginning that this angle up here would be the complement of that is 90 minus whatever that angle is. And the big idea for today's lesson was that the sine of the one angle is equal to the cosine of its complement, that is the 90 minus whatever that angle is. Let's look at this. Oh, the sine of this would be the opposite over the hypotenuse, b over c. The cosine of this angle is the adjacent over the hypotenuse, b over c. Let's look at this from a different perspective. What if I had my triangle, right triangle? This will be A, this will be B, this will be C. And I had this angle. Let's say it's 22 degrees. How much would this other angle be? What is 90 minus 22? When you subtract 22, you're going to get 68. So I could say that the sine of 22, which is A over C, is equal to the cosine of 90 minus 22, which is 68. Notice it's not the sine of 22 is equal to the cosine of 22. They're not, but they're equal to the complement of that. This is equal to A over C. And that is the big idea from the lesson. Now, in the cool down for today's lesson, I need to go to the lesson itself and get to the cool down. First of all, is a lesson summary. Please read it. You may remember from our table how this value was always the same as this one. When these two values were complements, we had the cosine of the one angle is equal to the sine of its complement. That's the big idea for today. And here it is using theta. Ooh, it's scary. No. Theta, the cosine of this angle is x over h. And it's the same as the sine, or the opposite of the hypotenuse, from this angle, x over h. For the cool down, you're supposed to solve these three questions. What is x, what is y, and what is w? So remember, the idea for today was that the sine of some angle, beta, is equal to the cosine of its complement, 90 minus beta. So if we have sine of 55, the cosine, what is 90 minus 55? You should get 35. The cosine of 28, this works backwards, by the way. What is 90 minus 28? Well, that should be 62, excuse me, 62. For this last one, in order to write w, it's going to be whatever z is subtracted from 90. And that's the big idea right here. Good luck and success.